with the ones that we skipped yesterday, you should have been putting starting by them. You should have your calculators out. Because we're going to learn how to use the two buttons on your calculator. And that's going to eventually lead us to logarithms. For the purposes of the word columns that we're about to do, even if you don't understand why it works, at this time, it's kind of one of those, it's like take my word for it type of a thing. And then eventually we're going to expand and learn more about logs. This is just kind of to get through the word columns. So let's go to this first one here. We're still purchased a rare guitar in the year 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Write an exponential function to model the appreciation of students' guitar. Use the graph to find the value of when the guitar will be worth $60,000. So we're not going to use a graph. We're going to do it algebraically. Actually, I said that. Sorry, I'm going to try something. The formula is going to be exactly the same. We're just going to use it to find a different variable. Fun. All right, let's do this. And that. I haven't had a chance to use it this year, so I'm excited. So now you can see me type it in the calculator. I'm excited. Hey. All right. So what does that word mean?
Once a year.
It means annual. We had our meeting yesterday. This formula is not going to show up on the quiz or the test. You have to know it. There is the formula for continuously compounded and for when it's compounded like monthly, that's when it has to get in there. Compounded. But this one you have to know. So it's the amount after some time is equal to the initial amount. It's a zero. Times the rate of change, the power of time. If you look at this formula or any other formula, this particular formula has 1, 2, 3, 4 variables, 4 unknowns. Anytime you want to solve for one of the unknowns, they have to give you all the other ones, or at least enough information to find all the other ones. Yesterday, we predominantly found that one, on the final amount. Today, the focus is going to be on finding this one. What's the difference? Well, where is that time located? Where? Don't think it's not a time. Yeah, it's in the expo. So we're going to have to learn how to get rid of a base. Let's go ahead and plug in some numbers so maybe this will make more sense to you. So the final amount, what's the final amount of the guitar? 60,000. What's the initial amount? How much do we buy it for? 12,000. And it was increasing by 14% per year, so my growth factor is 1.14 to the power of time. In order to get the t by itself, I have to get rid of the 12,000 and I have to get rid of the 1.14. The way that you remove a base, we haven't done this yet. We have not removed the base yet. In this case, that base is 1.14. We have to isolate it. So what I have to get rid of first is the 12,000. What operation is the 12,000 doing? So the opposite would be to divide. So I get 5 is equal to 1.14 to the power of t. So not that this happens a lot, but occasionally, your only experience with exponents is vice versa. Be like, oh, t to the 1.14, or the variable is the base, and you're just trying to get rid of the exponent. So the opposite of an exponent is a radical. So then you would take like a root of 1.14, but that's not the case here. Here, the exponent is the variable. I want to get rid of the base. The way we're going to get rid of a base is by using the log, but I'm using the logarithm. Now, due to technology, if you have a calculator that says multi, more than likely your calculator is capable of doing any type of base log. Every log has a base. When you see, here LOG, logs have bases. If you don't see the base, like the log that's on your calculator, the base is 10. There's another log on another type of log on the calculator that you might not realize. It's ln button. That's called a natural log. The base of that log is e. Remember that e number? That 2.71 that we saw yesterday? That really long irrational number? That's the base there. Traditionally, those are the only two bases that calculators could do. So we would have to use a property called change of base, which we'll expand on as we go. But we would use the property because the calculator were only programmed to do those two bases. Now, with these newer calculators, you can probably tell it what base you want. Okay, if you have a button on your calculator that looks like this, where it says log, and then it has like a little box on it, that's good. It's going to allow you to input the base you want. It makes life easier. But be careful because that won't necessarily be like on the midterm or final. So here's what I want to do. In order to get rid of, and I'm going to color code it so you can see it. In order to get rid of that base of 1.14, I have to take the log base 1.14 on that side. So I'm adding a log base 1.4 on that side. I have to do it on the other side also. Log base 1.14 of 5. That's going to get the base to cancel. So the t is going to be by itself. But now I have to figure out how to go ahead and put that into the calculator. If you have a calculator with MathPrint, you can tell the calculator, take the log of 1.1, log base 1.145 and just hit equals. You have one of these box. But if not, you're going to have to use a property called change of base. We'll expand on it more. What change of base says is we are going to change the base to one of the two bases that our calculator can do. What did I say the base of the LOG button is? 10, and there's also called a common log. What is the base of the LN button? And it doesn't matter which one. You can use whichever one. It doesn't matter. I typically use log, but on these first, I'll do one with log and one without that just to show that they both work. But what you're going to do is, let's say I'm going to use log. I'm going to take first the log, which is this is base 10, of the big number, which is 5, divided by log of 1.14. So what have I changed the base to? Before the base of the log was 1.14, what have I changed the base of the log to? I only put log, what is the base of the log? 10, yeah. Division allows you to do that. And you divide it up. Don't worry too much right now about why it works. Let's just understand that it works for these word columns. And then once we're done with this word column phase, we move on to we'll expand on lots. Did I tell you already the test you're getting back tomorrow? Yeah, that's tomorrow. The other teacher is working. All right. So how would you type that into the calculator? Well, if you have one of these, I would hit log. If your calculator auto generates an open parentheses, when I hit log 5, I'm going to close it and divide it by log of 1.14. I'm getting 12.283. This doesn't really tell me where to round. Now notice that the question did not say how long it would take. They want to know when that value would be. So when was the guitar purchased? And if you buy it in 2000 and 12.28 years passed by, when would it be worth that 60,000? It should be 2012. Yeah, probably somewhere around 3 months into the year 2012, but it should be around the year 2012. Anybody was not able to get that number on the calculator, holla. Let me know now so I can help you get it. See? Get it in. Order. Let's see. We did that one yesterday. This one was skipped because we. I think the next one with the star should be here at the bottom. Correct? The next one with the star on your notes. Then you said yes. How long would it take for a starting amount of 3,500 to double if the interest rate is 3% compounded annually? Okay, so this is compounded interest, but it's being compounded annually. You're supposed to use the formula where you're dividing by n and then multiplying by n, but in this case, what is n? 1. Now, what's anything divided by 1? Itself. What's anything times 1? Oh, good. So I can use the same formula I just used. What would my final amount be here? If the starting amount was 3,500, I want to know how long it would take to double. What's my final amount going to be? 7,000. And those of you that are particularly sharp, you're going to see something happen now. The original was 3,500 and 3%, so my growth factor is 1.03 to the power of time. But when I get the t by itself, what am I doing first? Divide by 3,500. Well, when you look at that, after I finish that first step, what did I end up with? 2, which is why they said, so on those problems where it says double, if you want to take a shortcut, I don't advise it for everybody, but you're going to ask for some problems say double and triple, that's the number you're going to end up on the other side. I have now isolated my base. How do I remove my base? Take the log on both sides. In this case, I want my log to be 1.03. So now I would log 1.03, log base 1.03. Again, cancel out. But the question is, how do I put that in my calculator? Put that in my calculator, I get the right answer. But that depends on the calculator. Some calculators allow you to type it as you see it, log base 1.03 of 2. And that's fine, but if you don't have that, you're going to have to do a change of base, which would be log 2 divided by log 1.03 for the time. In that case, log, you have to close the parentheses. If you have something like this on the screen, leave that parenthesis open, you get the wrong answer. Divided by log 1.03. Number you should be getting. About 23.45. What was my unit of time here? Years. It didn't tell me where to round, so this would be around 23 and a half years. Yeah. Questions there? Okay, we did that one. We did the second one. Let's go down here to this bottom one. How long would it take for $6,000 to triple in value? Okay, we're looking for how long. We're looking for a time. The triple in value if the interest rate is 3.25 compounded monthly. What's the number that goes with monthly? 12. So there's a couple of approaches. I'm going to do it the long way because I do not believe that everyone can follow this. But So the long way would be to say, okay, what is triple of 6,000? 18,000. So I'll write 18,000 as the final, 6,000 is the initial, and then 1 plus 0.0325 over the 12, and then times 12, and I don't know what t is, so let's say the t. I'm sorry that my t's up. So here would be the shorter way. My first step, regardless, is going to be to divide by 6,000. And when you look at that, what do I end up with on the other side when the base is isolated? 3. That's where that triple came from. So 3 is equal to 1 plus 0.0325 over 12 to the power of 12. Well, it'd be great if I could just simplify what's inside the parentheses. But when I put that into the calculator, 0.0325 divided by 12, see how it fills up the whole screen? It looks like it's a repeating decimal there. So what I would like to do is use the calculator's memory to my advantage. Okay. I know that this base right here, this huge base, is going to become the base of the log. I want to take the log of whatever that number is. I want to take it, and I can even let's put it in the 1 already, plus 1. And it's all your fault. Plus. So I don't want to round, because if I round, the only way to get this number and move it over here to my paper would be to round, and I don't want to do that because that's going to throw off my final answer. Oh. Go away. Go. So I'm going to do this. I'm going to say, all right, that's the log of this huge 1 plus 0.0325 over 12 of 3 is equal to 12t. What would the last step be? I wasn't able to get t by itself yet. I have to do one more step. I have to divide by 12. So here's what I'm going to use the calculator's memory and say, all right, in order to put this in the calculator, I know I need to do log 3 divided by this number. Since I already have that number in the calculator's memory, I'm going to put log of 3 divided by, and then I'm going to hit log. You should have an answer button. Most calculators have an answer button where you can use the calculator's memory. For this one, it's second. Then now in there, answer. And close it. What that now has done is everything here that's in the black circle. I took that log out, I did the entire left side. I simplified the entire left side. And the only thing left to do is to now divide by this 12. So that number that's now there, divided by 12, you should end up with 33.85. We were measuring time in years. So time is approximately 33. Yes. Where? From here? So to get from this step down to this point, I needed to take the log of both sides. But the log, like the base of that log, has to be whatever the base of the exponent is, this big number. The reason why I didn't simplify this, because if you look at my calculator, it was filling up the screen. And when it fills up the screen, that means that there's a good chance it goes on forever. Like, I don't want to round. Because if I were to round here, if I were to round in this step, I still have, I have to do the log, then I have to do the division. The earlier you round, maybe I don't get 33.85, maybe I get 32. Like, even if it's really close, your answer's going to be off. Okay? So I just took the log of this number, which might seem confusing the way I wrote it here, but it's less confusing on the calculator. If you look on the calculator, I'm just taking the log of this number. Like that parenthesis just gives me that number that's there. And then I just change the base to do log 3 divided by the log of that number. But since that was such a big number, I used the calculator's memory, and I just put log of the previous answer. The ANS means whatever the previous, like the last time you did equals, whatever it gave you as an output, that's the number it's going to put there where ANS is. And the calculator is not rounded. The calculator runs the entire amount. Does that make sense? Okay, we did this one up here yesterday. Alright, here we go. How long would it take for that same amount of investment to triple? Well, we did part of this yesterday. This going back to continuously compounded, which is that PERT formula. So if we go back and read the one that we did yesterday, like the work should be on your paper. They want to know how long it would take to triple. So you can either triple the actual number with 2200 times 3. 6600. But once you divide the 2200, you're gonna get a 3 on the other side anyways. Am I confusing anybody by putting that? I know I'm gonna be confusing. So then let's do it like I don't feel confident. So 6600 will just triple the 2200 and take those 2200. And this formula has E to the power of R. The rate here was 0.425, so 0.0425. I need to get the T by itself. In order to get the T by itself, I gotta get rid of the 2200, the E, and the 0.0425. Lord, which one am I gonna get rid of first? Alexis, which one am I gonna get rid of first? Yeah, sure. And this is what I was trying to get at. Once we kind of realize what's going on. The whole reason why we got the 6600 in the first place tripled. So that triple is going to end up here on this side. 3 equals E to the power of 0.0425. How do we get rid of a base of E? Mr. Romero, wouldn't that just be log base E? Yeah, it is log base E. There's a special name for that. There's a special name for log base E. Close. ln. ln means natural log. So what I'm going to be able to do here, I don't have to change the base. All I got to do is take the ln of both sides. No, that does not say in, it says ln. The ln is going to cancel out the e. So I'm going to do ln of 3 is equal to 0.0425 t. The last step is divided by that 0.025 divided by 0.0425. So on the calculator, I would take the ln of 3. So ln of log 3 divided by, not ln of 0.425, so divided by 0.0425. So it's going to take around 25.85 years. You can do the next one. I'll let you do it.
So
Tell me how many years have gone by.
So what would the ln do?
The ln just automatically gets rid of the base of e. There are two on a traditional calculator. This is not like 10 years ago. I mean, like the multi-views were not that popular. Like they weren't really around. So yeah, I almost every single calculator only had a log and an ln. So what base can the log button get rid of automatically? 10. What base can the ln button get rid of automatically? E. And other than that, you have to use the change of base thing when we divide it. But now it gets tricky because some of the calculators just let you input whatever base you want and it does that work for you. See if you can do that one, do the next one on your own. Yes, sir. What the one that she has is a multi. I'm guessing I haven't actually used it, but I believe hers allow me to put the base. But it doesn't let you do it. Maybe it's just Casio. I know there's some Casio that allow you to do it, but it doesn't look like it's allowed. Anybody here have a Casio? Anybody get the answer yet? Final amount is 83.96. Initial amount is 5,600. This doesn't do a very good job of saying how we're compounding, but since it's on the same page as compounded continuously, let's just assume that that's the case, that we're compounding this continuously. So that would be the e to the power of the rate, which is 0.0225 t. First step is to divide. That might give us too big of a number. Divided by 600. And you see how that number's too big? You could try to reduce that fraction, but what's the point?
We could still use the answer key. See the logarithm thing. Like what I did log the answer key divided by log 1.0.
You should not have to do that. Well, I will use the answer key, but what I won't be using is log. Why would I not use log here? You could, but it's a lot more work than you have to. My calculator already has a button that's gonna just get rid of it.
Oh, I didn't know that.
You can get away with using log and change your base. What button gets rid of e? ln. So I'm gonna just take the ln on both sides. ln. That's gonna knock out the e. At the end, I am gonna have to divide that 0.0225 number. But I would just do ln. You can hit your answer button, or look, if you don't want to use the answer button, you don't have to. You can just do 83.96 divided by 5,600. Just make sure that that's in the parentheses. And once you finish that, then divide by that extra 0.0225. What? So I'm getting 17.999. So close, I would just say the time is going to be 18 years.
So anytime we see interest, we need to use the E.
Anytime you see continuously compound. That's what was introduced yesterday. From what I understand, this formula will show up on the quiz, and this formula will show up on the quiz. Because apparently those are the only ones that show up on the reference sheet at the end of the year. The final. Alright, we did this one yesterday. Alright, let's do this one here. This is actually pretty scary problem here. All problems are scary, but it's not super scary. The world's current population in 2019 is 7.7 billion. It is estimated that the population is growing at a rate of 1.07%. Oh man, I just realized I did this wrong for last period. Damn, I read it wrong. You guys will do it right. Yeah, because we were getting last period that it was going to take 3 years. That's why I was saying it was scary. That it was going to take 3 years to get to the population of 10 billion. But I just realized now I read it wrong. This is not a growth factor of that. I read it as if that was going to be the growth factor. It's just the rate. Now it does say per year. What does per year mean? Annual. So we're definitely not using this. I don't know how this ended up there. We're not. This is not continuously compounded. This is just going to be the annual one. It says per year. So how long will it take for the world population to get to 10 billion? Now, because the original and the final amount are in this unit of billions, we don't have to write. How many zeros are there in a billion? 9. You don't have to write all the zeros. You could just write 10 for the final, 7 for the original, and now this is where I messed up. So the growth factor is not 1.07, it's 1.0107. Because you're adding, like you're turning this number into a decimal, and then adding that to 1. 1.07 divided by 100, which will turn into decimal, plus 1. To the power of time. How many years? First step would be divide by 7. 10 divided by 7 is going to be an ugly looking decimal, so I'll just leave it as a fraction. How do I get rid of a base of 1.0107? Yeah, it takes a lot. Look, just for fun, just to change things up and show you that they work. Unless you have a fancy calculator, your calculator does not do bases of 1.0107. So you're going to have to change the base. And just to show you that it doesn't matter what you change the base to. Just for this one, let's get crazy. Let's use LN. Okay? So now, really what I'm doing is, you know what? This is wrong because I'm not confused. Because when you write LN, you already have a base plan. But I'm just going to use log of 1.0107 log of 7. That cancels this out. My time is by itself. But in order to put that in the calculator, I'm going to do log. Put 10 divided by 7. But then I'm going to close that parentheses. I have to divide that by the log of that 1.0107. It's called change in base. That makes more sense. I was kind of scared. Not scared. I thought it was going to take 3 years. It looks like the time is going to take around 33.5 years. So when did we start counting? Because they want to know in what year. When did we start counting population on the board column? 2019. So if we get that number that we just got and add it to 2019, it's going to be somewhere in the middle of the year 2052. I'll probably dead by then. Any questions? Okay, let's see this bottom one down here. So we did this Carsville one yesterday. We didn't do that in which year? In which year will the population exceed 350,000? So final amount. This is an annual growth rate. So 350,000 is equal to what was the original population? 234,678. The growth rate is 3.2%, so 1.032. The first thing I'm doing is dividing the final population by the initial one. 35. Fills up my screen. It's around 1.5, but I don't like to round early. Eventually, so you're gonna have this big 300,000 by 2, 3, 4, 6, 7, 8 is equal to 1.032 to the power of t. I want to take the log of that 1.032 on both sides in order to get it to cancel. How would I type that? How would I type this left side of the calculator? How would I input that into the calculator?
The fraction divided by.
Very good. Log of that long fraction divided by log of 1.032. Since I already have it in my memory, I'll just do this for Julian. I'm going to use the answer button again. So I'm going to hit log. Second answer. Divided by log of 1.
Please pardon this interruption. As part of our ongoing safety and security procedures, at this time we are going to practice a hard lockdown. So teachers, if you would please check the hall and make sure that the hall around your classroom is clear, and then close and lock your door and move away from the doors and windows and remain there until one of our school police officers opens your door. We do have a number of school police officers on campus who are assisting with our lockdown this morning. So we will begin the lockdown at this time. Thank you.
It's going to take about 12.7 years. Now, they want to know in which year. Well, it says currently. So let's assume that this is 2020. What's going to be 12 years from now? Right now we're in 2020. Should be in the year 20. Would you round up to? Typically, is if it tells you, so like the way that this it's going to take around 12.7 years, right? So now they don't tell us what month we started. So we're assuming that it's at the beginning of 2020. If I start counting years in 2020, 12 and a half years go by, what year am I going to be in? They want to know in which year. It'd be 2032. I'd be towards the end of the year 2032, but I'll still be in that year. I haven't hit the new year yet. Okay, let's not worry about this one here. This is a half-life, and we're not going to worry about finding the constants. So, let's get to this one instead. Neptunium-237 is a radioactive element that is a solid at room temperature. Suppose that 100 milligrams of neptunium, that's where they get this 100 from. They've already modeled it for you. Decays according to that equation, where T is in hours. I'm telling you T is hours. About how many hours will it take to be reduced by half? What is half of 100 that we're starting with, 100 milligrams? 50. Or if you realize that 50 is going to go here where final amount goes, and once I divide by 100, what's 50 divided by 100? 1/2, or you can even put 0.5. Then the base is already by itself. I want to get rid of the base of E. How can I get rid of the base of E?
ln.
ln. Do I need to change the base? Do I have to do any type of special division or anything? No. It's already, ln is already going to get rid of that base of E automatically. Bam, it's gone. So I get ln of 0.5 is equal to negative 0.0308 T. Divide both sides by negative 0.0308 divided by negative 0.03. Wait, Mr. Romero, you said I wasn't going to divide. Oh, you're not dividing two different logs. You're just dividing to isolate the T. ln. ln of 0.5 divided by negative 0.0308. It's going to take about 22.5 hours. Okay, this first one here we already did today. This is how I'm going to take the triple. So let's do the volume 2 on the next page. If you deposit $200 into an account that pays 2.25% interest compounded quarterly, how long would it take for you to have $500 in the account? What's my final amount? 500. Equals, what's the original amount? 200. 1 plus. What's the rate? 0.0225. Or the decimal divided by what number goes with quarterly? 4. The power of that same 4 times the amount of times. This decimal hopefully won't be too bad. I'm going to first divide by 200. And that gives me 2.5. And then this, let's see, 0.0225 divided 225 divided by 4. So it looks like that base is the entire screen. Like 1.005625. How am I going to get rid of that base? Or, you're going to take the log of that same base. You're going to take the log base 1.005625. Take the log of base of 1.005625. But then, yes, the way you're going to put it into the calculator is to divide. I'm running out of space and we're also running out of time. So just to speed it up, it's going to be log of the 2.5 divided by log of 1.005. Am I done? What would I still have to do? I gotta divide by that extra 4 that was there. Divide by 4. I'm getting 40.5. 0.83. So how long will it take? The time is going to be around 40.83 years, almost 41 years. It doesn't really tell me to. It just says how long. So. You purchase a car for $28,000. It depreciates. What does that mean, depreciate? Yeah, that's going down. All appreciates means goes up and down. It depreciates means goes down and down. So here the fine. How long before it's worth only 15,000? So 15,000 is equal to it started off at 28,000. What's going to be my decay factor? You want to be fancy food all at once. If I'm losing 7.5% every year. Should be 0.925. 1 minus 0.075 is 0.925. Divide by 28,000. Divide by 28,000. All the zeros cancel. I gotta see the 50 over 28. And now to get the t by itself, I'm going to take the log of both sides out. So I got to take the log of 0.925, log of 0.925. So the calculator, I'll put log 15 divided by 28 divided by extra log of 0.925. And I'm getting around 8 years. See, like Jonathan, the down so close to 8, he has 8.00. All right, so just real quick to get this so that we can try to do as much as possible. So like now, this is what begins our introduction to logarithms, right? Which, when you start learning about logs, this is the first thing you learn. If you have an equation in exponential form, some base to a power is equal to something else, I can rewrite that in logarithmic form if I make the base of the log. That's kind of what we're doing today, matching the base of the exponent with the base of a log. And then you can really just switch the x and the y. Because the log base b is going to cancel this with the y by itself, and you end up with log base b of x. This tells you that when your base is 10, when you don't see it, that you don't have to write this 10, that's known as a common log. When your base is e, not only do you don't even write log, you just write ln, but that is known as a natural log. So the last thing I want to do today is go to this page here, and let's practice rewriting some both exponentials into logarithmic and logarithmic into exponential. Look, what is 2 to the 5th power? 32, right? So what we're seeing here is a statement of fact. 2 to the 5th power is 32. Can I rewrite that in logarithmic form? Sure. I would write log, what would be the base of the log? No, yeah, the base of the exponent becomes the base of the log, and then you can just switch the 5 and the 32. So the question would be then, what is log base 2 of 32? 5. If in your calculator you put log 32 divided by log 2 is 5. How about the next one? What would be the base of the log if I were to rewrite this in exponential, logarithmic form? Log would be, the base would be 3. So what is the log base 3 of 1 over 9? If I put in my calculator log 1 over 9 divided by log 3, what would I get? 5 to the 3rd power is 125. But if I keep the base as the base of the log, what is log base 5 of 125? 3. It is 3. When you're bored and you go home, you can put that in the calculator and see it works. Now look at the next one. The next ones are starting off in log, let's convert it to exponential. What would be the base of the exponent? 6. What would be the exponent? And now we can confirm. When we're used to exponents, we know that 6 squared is 36. On the next one, what will be the base? 49. 49 to the 1/2 power gives you 7. Sorry, my exponent. This is a little bit redundant here. Did they have to write that 10? No. Because if you look at the next one, they just wrote log. When you just write log, we assume it's log base 10, so we know the base is going to be 10. What's the exponent? What's the exponent of 10? -1. What is 10 to the -1 power? 1 over 10. The last one. What's the base?
10.
10. When they don't write it, it's 10. What's the exponent?
3.
What's 10 to the 3rd power?
1,000.
This is like a little taste of logarithms. Tomorrow we'll continue with logs and we'll also do back to that.